Hi guys, myself Manoj.M. Welcome back to the MANJULA.K MANOJ.M YouTube channel. Yeah, in the last video we have discussed about the inverter and the DC characteristics and the transfer characteristics, and we also came to know how to create the symbol. Yeah, we have discussed all the things in this video. We are going to discuss about the NAND gate, and we make the schematic here, symbol, DC characteristics and transfer characteristics. All are in the same video. Yeah, in the last video, we have made a separate video for that schematic and a separate video for the symbol. In this video, we can make one video detailed with explanation of all the concepts and all the theory parts. Yeah, before we moving to make the circuit, yeah, we need to know some of the theory part that will help us to make the circuit clearly and understand the concepts clearly. Yeah, we need to know the theory. If you know the theory, yeah, it's a brush up for you. Yeah, let's begin the video. Before that, if you didn't subscribe my channel, please subscribe my channel and hit the bell icon, guys. Yeah, let's open the one notepad. Yeah, we are going to discuss about CMOS VLSI NAND Gate. Okay, done. Yeah, let me write the symbol of this NAND Gate symbol. This is, and if we put that the symbol and then this become the NAND gate. This is A, this is B, and this is represented as Y. Okay, next let us write the schematic of the NAND gate. Schematic. For the multiplication, we know that we need to write the NMOS in series. Okay, this is A, this is B, this is the gate, this is the gate, and then ground the substrate. This substrate is grounded, and again make this substrate grounded. Then write G and D here. That's it. Yeah, this one is the drain. We know this one is the source, this one is the drain, and this one is the source. Yeah, okay, these things are done and drain. Right, for them, for this, yeah, PMOS, we need to know that we need to write it oppositely. That's it. Let's write this also. If it is series, then in the PMOS it's became the parallel. We know this thing. Yeah, okay, put two PMOS in parallel. Then this is A, this is B, this is the gate, this is the gate, then this is the source, this is the drain, and then this is the source, this is the drain, and make the substrate to the VDD. That's it. Okay, this is substrate, this is the substrate. Connect it and then make it to the VDD. This is drain. Output here y is equal to A dot B whole bar. Yeah, these things are done. Yeah, my handwriting is does not that much good. Yeah, I hope you all understanding what I am writing. Then here we write the truth table. Truth table. Okay, truth table of NAND gate. Yeah, here this one, this is A, this is B, then this is Y. Okay. Then here, then here, then here. 0 0 0 1 1 0 1 1. Yeah, it's the output is the opposite of the NAND gate. This is 1, this is 1, this is 1, this is 0. Yeah, this is the output of this. That's it. Yeah, let's move on to the cadence and to the circuit. Yeah, I am moving on to the cadence. Yeah, here we know that we need to click on the terminal and write the virtuoso, and it will take its time to load. Yeah, it's loading. Then click on file, then click on new, then click on Salvio. let's move on to this and select the VLSI and give name as NAND NAND. Okay, then click OK. Yeah, it takes time to load. It will open. Yeah, this is open. We need to make the schematic here. Press on I and then select on browse. Then move on to GPDK 090. Take the two NMOSs here, NMOS 1V, and then click on symbol here. Then close this. Then again hide this. Put two NMOS in the series and then enter escape. Again then press I, then click on brush, then move on to the PMOS 1V, then close this, then again hide this, put two PMOS in parallel, that's it, then enter escape, then click on W, then connect it to it, then again click on W, connect this and this. Okay, then again click on W, make it to the VDD. Then again click on W, make it to the VDD. Okay, then from here to here connect it. Then from here to here connect it. Okay, then click on W, make it to the ground. Then make the substrate of this animals to the ground, then enter escape, then again make this substrate to the ground, that's it. Okay, then little bit extend is to put the ground. Okay, these things are done, and then yeah, let me connect these to let then click on this and let's connect this also, then click on escape, then click on W from connect from here to here, then click on W from connect here to here, then from here may click on W and move on to here, then take above this by clicking on W, then click on P. Yeah, inputs are A, B, VDD and G and D. Okay. A connected to here, B connected to here. Then connect the VDD here, click on or it will rotate. Then click here, it will come there. Then click on R, then connect the ground here. The inputs are connected now. And then click on P, then make it to the output. Then output as V out, okay. Then press enter, then rotate this. Done. These things are done. Click on right mark. Done. Then come here. Check schematic. Check completed with 0 errors. VLSI 9 schematic saved. Then we need to create the symbol for this. Then move on to the create. Then click on cell view. Then from cell view, it's okay. Then click on OK. Then we know that left pins are A and B. Then cut this. Then make the top pin as VDD. We know that. Then the bottom pin is G and D. Then click on OK. It will open the symbol. Then give this name as NAND. Then click here and remove it. It's not needed as of now. Okay. Enter the backspace. It will move. For this, then click on check and save. It will automatically correct it. Yeah. Then the symbol is done. And then again click on file. Then move to the new. Then click on cell Y to verify the transfer characteristics. And for the DC analysis, then make it as 91. Then click on enter. Yeah, let's zoom it. Then press on high. Then click on browse. Okay. After clicking on browse, it takes time. Then move on to this VLSI. Then click on NAND. Then it will select that symbol. Then close this. Then hide this. Then put it here. Then click on P. Give the name as V. Enter and then rotate it. Then click on W for connect here to here. Then click on P. It will here in the output. Then change it to input and give the pin name says A, B, VDD and then G and D. Then click enter, put A here, put B here, put VDD above and put G and D below. That's it. Then click on W. Then connect from here to here. Connect here to here. Then click on W. Connect here to here. Then for the VDD, click on W. Connect here to here. Then click on A for this properly fit into the screen. Then click on right mark. You are done. Then check schematic. Check completed with no errors. VLSI 91 schematic. It came says. Then again click on this thing. Then click on launch. Then click on ADL. Guys, then click on this. Then move on to this. Then make the GND as 0 volt. Then click on bit. Then move on to the DC. Then make DC voltage as 0 and then click on enable. Then click on apply. Yeah, it's done. Then move on to the VDD. Then click on bit. Then click on DC and make it as one word. Then click on enable and then click on apply. It's done. Then click on yeah. Then click on this pulse. Then set the DC voltage as 1 volt. Voltage 1 is 0 volt. Voltage 2 is 1 volt. The period is 40 nano and the pulse width is 20 nano. It has typed the automatically. Before that I had checked it. That's why that's I taken okay. If you initially don't come, you need to tap it. Then click on enable. Then click on apply. Then move on to the B. Then move it to the vehicles. Here also I did. I think this is 40 nano, 20 nano. I think both should not be same. Kindly change it to 20 nano and 10 nano. Okay. Make here as 20 nano and then the pulse width as 10 nano. Okay. And then click on apply. Then click on OK. That's it. And then check it whether everything is on. No, B is not on. Click on this. Click on enable. Okay. Then click on apply. Then click on OK. Then click on output. Then click on to be plotted. Then select on schematic. Click on A and then click on B. Then click on V out. Okay. Then click on analysis. Then choose. Then move on to transient. Then enter stop time as 200 nano. That's it. Then click on tab. It will enable. Then click on moderate. Then click on OK. Then click on run. Yeah, it's running. Yeah, the transfer response will come. Yeah, let me check. Guys, we know that when the both the inputs are 1 1, it should be 0. When it is 1, it is 1 0. Then 1 0, it was as 1. Then it happens for the delay. That's it. Okay, if we minimize this, we know there is some delay for that wise. It will come down and go up. Otherwise, for 0 1, it's 1. For 0 0, it's 1. Yeah, the transfer response is correct. Then minimize this. Then we need to know that we need to do the DC analysis. For the DC analysis, we need to know that we need to give the same input to the A and B. If we try to do the DC analysis, then click on DC, then click on save DC operating point, then click on component parameter, then click on select component. If you click on A, it will show you the error so that you close this. Then remove all these things here, cut, and then delete this. Then check this whether A and B are gone. Yeah, no, it's not gone because I think we didn't. Yeah, it's not gone because we need to remove from this location. To remove this, select this and click on delete. Then delete this. Then delete this also. Then click on W, connect this and connect this to B and then click on I, then click on browse. Then yeah, Vpulse is there. Simply make it as close and then type here has this is 1 volt and make it 40 nano. Then make the pulse width as 20 nano and then enter the tab. Then click on hide, it will hide. Okay, then place here, then click on W, connect from here to here, then click on W, connect from here to here. Okay, then click on right mark. Okay, kindly check if there is error or not. Comes this side. Schematic check completed with no error. VLSI 91 schematics saved. Okay, then click on analysis, then click on choose, then click on DC analysis, then click on save DC operating point, then click on component parameter there, then click on select component, come here and then click on this, then click on DC voltage, then click on OK, then come here, start as 0 and stop as 1, then click on enter. Okay, it will go and then move this to a little bit this slide, then for this, then cancel this transient, then click on outputs, then click on to be plotted, then click on select on schematic, then click here, then minimize it to select that output side, then click on this. Yeah, the output is selected, then click on this run. Okay, it will take some time. Yeah, the DC response is come. Yeah, in this video we have done the schematic symbol DC response and the transfer response. Yeah, everything is done. I hope you understand completely how to do it for NAND gate. I hope this video help you. If this video help you, please like the video and share with your friends. Your support matters a lot, guys. I hope this video is clear and cut explanation given to you. Thank you for watching, guys. See you in the next video.